Hello everyone. So what to do now is I wanted to show you how to do some momentum problems in case you're having, particularly on problems 4 and 5 on the homework. So I've written an example problem. We have two objects colliding. One has a mass of 4.3 kilograms and is moving to the right at 2 meters per second. The other has a mass of 3.3 kilograms and is moving to the left at 5 meters per second. And I've given you two possible solutions. One is to find two problems. One is to find the final velocity if they combine totally inelastically. And the other is to find the final velocity if the 4.3 kilogram mass, if the 3.3 kilogram mass continues after the collision with a speed of 0.5 meters per second to the left. Now let's just set them up. I always like to sketch a before and after picture, so I'm going to draw these things coming together. There we go. So we've got one that's 4.3 moving to the right. We draw it moving to the right. Underneath that we write 2 meters per second. A little smaller. Then we have the other one moving to the left. And under that, we have a speed of 5 meters per second. Now, and then just underneath both of them, I'm going to write before. Because in a collision, you have a before and you have an after. Now, afterwards, if it's a totally inelastic collision, they end up sticking together. So I'm going to indicate that as a big globby thing like that. Now we don't know what the speed is. I can try to predict what the speed is going to be. I can try to predict the direction. So I'm going to imagine it's moving to the left. I don't know that it will be, but I think it will be because I made the one moving to the left so much faster. But I'm just going to label this one V. And you want to notice that the masses of this one is going to be combined. So if this one had a mass of 4.3, and this one has a mass of 3.3, and this one has a mass of 7.6. Okay, now we need to indicate which way is positive. And since the whole thing is, I think, is going to be ending up moving to the left, I'm going to go ahead and say positive is left. And that makes this number here, this number, a negative number, negative 2 meters per second. Then we can use our equation, and that is that the momentum before equals the momentum after. Yeah, and so the before the collision, we've got a mass of 4.3 times a speed of negative 2 plus a mass of 3.3 times the speed of negative 5, and that equals a, I'll just move this down so you can see better. There. Equals a mass of 7.6 times the speed of v. We don't know what v is. Sorry, this one is positive 5, it's not negative 5, there we are. So, this gives us negative 8.6 plus 16.5 equals 7.6v, which gives us 7.8 I believe. No, 7.9. Well, here. Let's just use the calculator. So we want 16.5 minus 8.6 is 7.9. So we get 7.9 equals 7.6 V. And so V is equal to 7.9 divided by 7.6, which is 1.04 meters per second. And since it's positive, we know that means left, because we defined positive as being left right there. Okay, so the answer to this one is 1.04 meters per second to the left. Okay, now let's do the second one. And for the second one, I'm just going to delete some things. I'm going to delete this. I'm going to delete this. And I'm going to delete that. Our arrow got moved around. I'll put the arrow back. So now we have a new after. So for part 2, the final velocity of the 4.31 is given. So now we have an after case where we've got two objects here. We know that this one has a mass of 4.3 still. And we know that this one has a mass of 3.3 still. I don't know why this arrow keeps moving around. We know that 3.3 has a final velocity to the left, so it's a fair guess that the 4.3 also has a final velocity to the left. I don't know how else it would work. And we can write this as 0.5 meters per second. There. And then this one is V. We don't know what it is. However, we can still do the same thing we did in the last problem. We can say momentum before equals momentum after. And before the collision, we have the exact same thing. We have 4.3 times negative 2 plus 3.3 times 5. But now we have a different situation. They don't stick together. We have the 4.3 mass. We don't know what that final mass is, so we'll call it V. And we have the 3.3 mass where we do know what that final velocity is, and that's 0.5 to the left, so it's positive. Now we're just solving this equation for V. We have everything else set up, so we get negative 8.6 plus 16.5 equals 4.3 V plus 1.65, and I think we can combine like terms. You remember this was 7.9 on this side, 7.9, and we want to subtract off that 1.65, and that equals 4.3 V, and so that gives us 6.25 equals 4.3 V, and we just use our calculator to get 6.25 divided by 4.3 is 1.45. So V ends up being 1.45 meters per second. And that's still positive, so it's going to be to the left. So we can write that up here. 1.45 meters per second left. So hopefully this will help you out.